Okay, let's start. It's a lot of slide. You see, 121. Can you finish? 121 slide. No. It's not all about this one. Like I'm preparing slide for your future generation, right? It's a lot of slides. Okay, no problem. So you will start from okay. So Koli, you will start from here. So আমি একটু বলে নিই তার আগে আজকে আমরা যে টপিকসটা পড়বো সেটা আমরা সকালে দেখলাম যে রক কার্ভ, রাইট? রক কার্ভ মানে কি? What is
Receiver operating characteristics.
রিসিভার অপারেটিং ক্যারেক্টারিস্টিক্স? এটার মাধ্যমে আমরা কি করি?
স্যার ভ্যালিডেশন চেক করি, মানে
ভ্যালিডেশন চেক করি। কিসের
মডেলের
ভ্যালিডেশন?
মডেলের ভ্যালিডেশন, যে
তার
আসলে
মানে তার প্রেডিক্টিভ অ্যাকুরেসি।
প্রেডিক্টিভ অ্যাকুরেসি, এক্স্যাক্টলি।
মানে তার প্রেডিক্টিভ অ্যাকুরেসিটা কেমন? তো নরমালি ওই রক কার্ভের ভিতরে কি কি জিনিস ছিল?
স্যার হচ্ছে AUC ছিল, তারপরে হচ্ছে
Area under curve,
সেনসিটিভিটি
right?
ছিল, তারপরে
Area
হচ্ছে
under curve,
স্পেসিফিসিটি ছিল।
এক্স্যাক্টলি, সেনসিটিভিটি, স্পেসিফিসিটি, এই কয়েকটাই তো নাকি?
হ্যাঁ এই কয়টাই।
ওকে, আরেকটা পড়েছিলাম আমরা কনফিউশন ম্যাট্রিক্স।
হ্যাঁ,
কনফিউশন ম্যাট্রিক্স, ওই দুইটাই হচ্ছে আমাদের আজকের টপিক। সো এখানে অনেকগুলি স্লাইড অ্যাড করার চেষ্টা করেছি, আমি মনে করি এটা তোমরা বুঝতে পারবে আজকে। সো Koli will start from onwards. If you have any problem, like you can tell me, please, no need to tell me sir, you can just tell me, hey, next, okay? You understand, Koli?
Yes, sir.
Okay, Koli, let's start. You will just read slowly so that the students can understand, okay?
Okay, sir.
I was fast because the time was limited, but now, from now onwards, the time is huge, like we can extend our class until evening, so no problem. Try to talk slowly, okay? Try to talk slowly, Koli.
Okay, sir.
Okay,
Okay, sir.
let's start.
Okay, sir. ML classification accuracy. Evaluating a model is a major part of building an effective medicine learning model.
Medicine,
Machine learning. I'm going to explain.
no, এই পর্যন্ত স্টপ। আমি যখন মানে প্রসেস করব, দেখবে যে স্লাইড আসতেছে নতুন কিছু, তখন নেক্সট, যেহেতু এখনো কিছু বলি নাই, তো ওটা না, ঠিক আছে?
Okay,
এটা তো
sir.
লাস্ট এর মাঝখানে তো আরো আছে। আবার বলো, এই যে আমারটা ফলো করো, তুমি বলার পরে হতে পারে আমি কিছু বলতেও পারি, সেজন্য একটু ওয়েট করবে। ক্লিয়ার?
Yes, sir.
আমাকে
Okay,
একটা লাইন
sir.
তুমি বললে, আমি পরের স্লাইড আর গেলাম না, তার মানে আমি কিছু বলবো। ক্লিয়ার?
Okay, sir.
গুড, লেটস স্টার্ট अगेन। আর ওই টপিক, বাম পাশের টপিকস বলতে পারো, না বলতে পারো, ওকে, সব ঠিক।
Okay, sir. Evaluating a model is a major part of building an effective machine learning model.
Okay, so what do you mean by this sentence? This sentence means if you want to build an effective machine learning model, okay, then you have to evaluate the model. মানে আমরা যদি একটা ইফেক্টিভ মেশিন লার্নিং মডেল বিল্ড করতে চাই, মানে ক্রিয়েট করতে চাই আর এস্টাবলিশ করতে চাই, এটা একটা ইম্পর্টেন্ট পার্ট হচ্ছে সেটাকে তোমাকে ইভালুয়েট করতে হবে। সো ইভালুয়েশন অফ এ মডেল ইজ এ মেজর পার্ট অফ বিল্ডিং অ্যান ইফেক্টিভ মেশিন লার্নিং মডেল। থ্যাংক ইউ।
The most frequent classification evaluation metric that we use should be accuracy.
Okay, as we mentioned, we have to evaluate the model. For what purpose? To build an effective machine learning model. So if you want to evaluate the model, you have to use a metric. So normally or traditionally, we tell or we recognize or we use this metric or measurement as accuracy. So accuracy is one kind of classification evaluation metric.
You might believe that the model is good when the accuracy rate is 99%.
Exactly. So suppose you got your accuracy, like your model gives you the accuracy 99%. What normally we can believe, or what we normally we can conclude, or what we can normally we can interpret is that our model has 99% accurate, right? You might believe that, but colleague,
However, it is not always true and can be misleading in some situations.
exactly. Accuracy is a common term. Normally, accuracy is a common term. Like in a normal regression model, if you can calculate the R square, right? So R square will give you the overall goodness of fit of your model. Suppose you got 99%, right? So normally we can tell that, okay, our model is accurate because we got 99%. But in reality, in time series data or in the data science world, this is not always true. Better, the result can be misleading in some situations. So we can look for some other metric or other measurements, which we already told you, like the sensitivity, specificity, area under curve, right? True positive rate, false positive rate. So normally accuracy is a general term, but suppose you got accuracy like 99%, it's not sometimes enough to accurately predict your model. Better, we can use some other evaluation parameter. You understand what I mean?
Yes, sir.
Okay. Then you can tell me. Then you can tell the next sentence.
I'm going to explain the four aspects as shown below. It's already finished. I'm the confusion matrix for a two-class classification problem. The key classification matrix, accuracy, recall, precision, and F1 score. The difference between recall and precision in specific cases, decision thresholds, and receiver operating characteristic, ROC curve.
Okay. So as you see, your prediction might be misleading. Misleading means although you got the accuracy 99%, this is a general accuracy measurement. You can measure even using the normal R square value for evaluating a normal simple linear regression model. But however, it's not always true because there are some other classification metrics as well. So what are those classification metrics? Like the key so for the misleading result, we can now discuss some aspects. And these aspects are the main topic of our today's class. So what we are going to discuss today, number one, the confusion matrix for a two-class classification problem. The key classification metrics, that means what are the traditional, not traditional, what are the machine learning classification measurement or metrics you can use for the evaluation of the prediction of your model. What are those matrices? Accuracy is a general one. And using this accuracy, you cannot tell that your model is 100% accurate or 99% accurate. Better, you can evaluate also using recall. Recall is another classification metric. You can take help from the precision. So precision is one kind of another classification metric. And F1 score is another classification metric. So accuracy, recall, precision, and F1 score are classification metrics or the accuracy measurement by which you can accurately classify your model. Okay, and also you will have some glimpse of idea regarding the difference between recall and precision in specific cases. Then what are the difference between recall and precision? You will have some idea about after this lecture. And finally, decision thresholds and receiver operating characteristics. Of course, you are gonna learn something what is about rock curve? That means receiving operating characteristics.
In any binary classification task, we model can only achieve two results. Either our model is correct or incorrect. In the prediction where we only have two classes.
Consider one regression model, logistic regression model. So this model could be your classification regression model. Why? Because using this logistic regression model, you can classify either two classes, correct, incorrect, okay, male, female, or good, bad, right? So by nature, logistic regression is a binary classification regression model where the response variable is categorical in nature, and the category of that response variable are only of two types, right? That's why the binary. So in a binary classification task, we model can only achieve two results, right? The outcome is gonna be only two. That's why the classification is categorized, as the name suggests, like binary classification. So either our model is correct or incorrect. So these are some of the examples, right? What binary classification means.
Imagine we now have a classification task to predict if an image is a dog or cat.
Let's imagine a classification problem. What is the problem of that problem? The problem is to predict whether the image you saw already is a dog or a cat.
In supervised learning, we first feed or train a model on training data, then test the model on testing data.
Okay. So what we can do in supervised learning, as you know, in supervised learning, the input must be leveled, right? So we first fit or train a model on training data. First, you have to fit your model on the training data. We already see in our previous class in the decision tree algorithm, what we did, we have the data and we split the data into training data and test data. And decision tree is definitely a supervised learning algorithm. What we did, we fit or train a model, that means the decision tree model, on training data first. Then what we did, we also test the model on that testing data.
Once we have the model's predictions from the X-test data, we compare it to the true Y values, the correct levels.
Exactly. Then the word or then the contents accuracy comes. So once we have the model's prediction from the X test data, okay, we compare it to the true Y values. So this is called the error. Observed minus predicted. Observed minus predicted. Suppose you have two values, Y and X. Y denotes your exam result and X denotes like your gender, right? So now I run a regression model. So what is the actual Y here? The actual Y is like the result, what I collected from you. Then after running the regression, I can run a regression. Y curve, estimated Y is equal to, suppose alpha is like 0.1, beta is 0.2 into X. So what you can do, you can replace the value of X, okay? You can replace the value of X, that is gonna be your predicted value. So what is the error here? Observed, which is already collected, the true Y value, and after running the regression, you are gonna get the predicted Y value. So what is the difference between observed and predicted value? This difference is called the error, okay? So what kind of model will be the most accurate model? Do you know, as far as the error is concerned, if I ask you, tell me about the accuracy of a model based on the error, what do you think? What should be your interpretation? You don't get my point or question? No?
No, sir.
The less, James, Mr. James is singing, the less the error, the accurate the model. একটা মডেলের এরর যত কম হবে সেই মডেলটা তত বেশি accurate হবে। Clear?
Yes, sir.
Good. Next.
We feed the image of dog into our trained model before the model prediction. The model predicts that this is a dog, and then we compare the prediction to the correct level.
Okay. As you know, in our train model, what we did, we just put our data in the train model before the model prediction, right? প্রথমে তো আমাকে প্যারামিটারটা এস্টিমেট করতে হবে। Then we can use the parameter for the model prediction. The model predicts that this is a dog. যদি সেটা accurately predict করে, then we compare the prediction to the correct level. That means the level of the dog was correct. That means it is not cat.
If we compare the prediction to the level of dog, it is correct. However, if it predicts that this image is a cat, this comparison to the correct level would be incorrect.
Yes, so if the classification is misclassified and it replaced the classification, whether it was supposed to be cat or dog, but you are telling this is cat. So the level would be incorrect in that scenario.
We repeat this process for all the images in our X-test data. Eventually, we will have a count of correctly matched and count of incorrect matches.
Exactly. So I don't think this is, I need to repeat.
The key realization is that not all incorrect or correct matches hold equal value in reality. Therefore, a single metric won't tell the whole story.
Exactly. So what is our realization here? Only accuracy is not enough to accurately predict your in the previous slides, or this slide, in fact, the previous sentences, the frequency or the number of the incorrect or correct matches cannot be or couldn't be equal, right? So a single metric like the accuracy is not enough to tell the whole story that your model is correct. It means তার মানে একই কথা আমরা বলছি যে accuracy দিয়ে শুধু আমরা বলতে পারবো না তোমার মডেলটা 100% accurate, because accuracy আমরা যে ফর্মুলা ইউজ করি, দিস ইজ এ ভেরি সিম্পল ফর্মুলা। মানে আগের সেন্টেন্স থেকে যদি আমরা accuracy বের করতে চাই, কিভাবে বের করব? নাম্বার অফ কারেক্টেড ক্লাসেস divided by number of incorrect into 100%, something like that or not? আছে কারেক্টলি ক্লাস আছে,
Yes.
তুমি তোমাকে বললাম ফাইন্ড আউট দা মানে ফ্রিকোয়েন্সি অফ কারেক্ট ক্লাসেস, কিভাবে বের করবে? দিস ইজ আ সিম্পল ফর্মুলা লাইক দ্য ডিভিশন রুল, লাইক হচ্ছে কারণটা হচ্ছে তোমার ম্যাচেস মানে ইনকারেক্ট ম্যাচ কারেক্ট ম্যাচ, ইনকারেক্ট লেভেল কারেক্ট লেভেলে যে সংখ্যাটা সেটা সমান নাও হতে পারে। সো ইটস গোনা বি ভেরি ডিফিকাল্ট। It won't tell you the story, like you cannot use only a single metric, single measurement accuracy. Rather, you should go for the other matrices like accuracy, not only accuracy, sorry, accuracy is the normal one, like the AUC, area under curve, sensitivity, specificity, F1 score, right? So there are some other metrics as well. We'll learn in the next slides.
As mentioned, accuracy is one of the common evaluation metrics in classification problems. That is the total number of correct predictions divided by the total number of predictions made for a data set.
Okay, so এটাই আমরা বলছিলাম। দেখো তাহলে accuracy আমরা কিভাবে বের করব? এটা ভেরি ইজি, total number of correct prediction divided by total number of predictions, okay, made for a data set. So this is a simple formula for the accuracy. So can you calculate this one? Is very easy. Like suppose you have a রিগ্রেশন প্রবলেম। আবার বলি, তোমার এক্স এবং ওয়াই দুইটা ডেটা আছে, তুমি জানো তো তোমার ডেটা সাইজ যেহেতু ছোট, তুমি জানো তোমার ওয়াই কোনটা। এখন তুমি র্যান্ডমলি স্যাম্পল সিলেক্ট করেছো, তোমার ব্যাচে সবাইকে বলেছো যে তোমার রেজাল্টটা বলো তো। এখন দুষ্টমি করে ফারহান, একটু দুষ্ট ছেলে, বা সে ঘুম থেকে দেরি করে ওঠে, ঠিক না? এখন সে তার রেজাল্টটা মানে মনের ভুলে ভুল করে ফেলেছে আর কি, ঠিক না? অথবা কোন একটা মিস্টেক করেছে, ওই মিস্টেকের জন্য তার অরিজিনাল রেজাল্টটা সে বলেনি, ঠিক না? তারপরেও তুমি কিন্তু জানো তার ট্রু রেজাল্টটা কত, ঠিক না? তো এরকম কারেক্ট প্রেডিকশন ডিভাইডেড বাই টোটাল নাম্বার অফ প্রেডিকশন, সেটা আমরা কিভাবে বের করব? এক্স এবং ওয়াই যদি তোমার দুইটা ডেটা সেট থাকে, আমরা রিগ্রেশন মডেল রান করব, সে আগে কথাই, এবং রান করার পরে আলফা বিটা ভ্যালু বসিয়ে এক্স এর ভ্যালু বসালে যেটা পাবো প্রেডিক্টেড ওয়াই। এই প্রেডিক্টেড ওয়াই হচ্ছে ট্রু প্রেডিক্টেড ওয়াই, এন্ড অবজার্ভ ওয়াই ফারহান যেটা বললো, তাহলে এই দুইটার মধ্যে যে পার্থক্য, রাইট? এবং কারেক্ট প্রেডিকশনকে আমি ওয়াই কার্ভ অনেকগুলি পাবো, তাহলে সাম করবা ওয়াই কার্ভ ডিভাইডেড বাই টোটাল নাম্বার অফ প্রেডিকশন, তুমি কয়টা প্রেডিকশন করেছো, কয়জন মানুষের, তাহলে যেটা হবে সেটাই হবে যে টোটাল নাম্বার, সেটাই হবে যে তোমার অ্যাকুরেসি। তো তুমি অ্যাকুরেসি পেলে 99%, যদিও ফারহান বলেছে যে তার রেজাল্টটা ভুল বলেছে, ঠিক না? তো এরকম 99% অ্যাকুরেট দেখালেও এটা কিন্তু পারফেক্ট হবে না, কারণ দেয়ার আর সাম মেনি আদার রিজনস, other characteristics, other properties. So it's better to look the other matrices, other measurement as well, the named like area under curve, precision, recall, right, F1 score, sensitivity, specificity.
Accuracy is useful when the target class is well balanced, but is not a good choice with unbalanced classes.
That means the data we just talked about was not balanced because Farhan did some mistake. Farhan did response like a lazy guy, and he really did some mistake. As far as his result is concerned, the true result was supposed to be 3.5, but he used to tell you like his result is 2.5. So this is a mistake. So the mistake created our classes unbalanced. So when your data is unbalanced, accuracy is not a useful measure. But when the data is balanced, that means there is no wrong, and you actually know the true scenario of your data set. That means what kind of classes. Suppose you have a 50 data and all the classes of your data like CGPA, good, bad, good, bad, good, bad, right? So you know all the classes of your GPA. Then you can say the data is balanced enough. So in that case, what you can use? You can use accuracy. Otherwise, you cannot use accuracy. You can use accuracy and other in alternatively you can use other measures. Then you can compare what changes are gonna be made in the classification accuracy.
Imagine we had 99 images of the dog and only one image of a cat in our training data. Our model would be simply a line that always predicted dog, and therefore we got 99% accuracy.
This is the same example I just talked. Just you can replace Mr. Farhan with a dog. Suppose Farhan is a dog, okay? So you can just develop. Okay, I will eat the khichdi. Okay. Thank you. Okay. So Farhan is a dog. Then you can imagine, right? Fully imagine. You can imagine the images. What could be the predicted dog, and therefore you get 99% accuracy. Then
Data is always imbalanced in reality, such as spam email, credit card fraud, and medical diagnosis. Hence, if we want to have a full picture of the model evaluation, other metrics such as recall and precision should also be considered.
exactly. So what our reality says, in our reality, data is always imbalanced, right? Suppose today we take a quiz exam. Suppose you are instructed to attend in a quiz exam, right? So what you could have the result. Definitely the result is gonna be imbalanced because we live in an imbalanced society. The way we structured your life was imbalanced. That means the teachers you got starting from the primary school to the tertiary level. And these things made you imbalanced. So in reality, data is really imbalanced, such as the spam email, credit card fraud detection, and medical diagnosis. So when you are living in an imbalanced society, right, you don't rely only one teacher. You don't rely only one person, right? You have to compare the good person living near you. But I'm not sure whether you are looking for that particular correct person or not, but you are requested to live, or you are requested to follow the correct guy that can shape your life in a better way.
Classification accuracy is a metric that summarizes the performance of a classification model as the number of correct predictions divided by the total number of predictions. It is, sir,
Next.
it is easy to calculate and sorry,
Intuitive.
intuitive
It's a
to
very good one.
understand, making it the most common metric used for evaluating classifier models.
What is the classification accuracy? It's nothing, as we mentioned earlier. What is the calculation of class accuracy? When the accuracy is going to be used in classification, the name will be changed only. The formula remains unchanged, right? So why you need to use the classification accuracy? It's easy to calculate, easy to understand, easy to apply, right? And easy to calculate, and making it the most common. That's why this calculative nature making the classification accuracy as one of the most common metric used for evaluating classifier models. But this is not sufficient. As I told you, classification accuracy is not, normal accuracy is not sufficient. You need to go or further look for the other matrices, like the good correct matrices.
What is the good accuracy for machine learning classification? What is the best score?
So if I ask you, what is the good accuracy for machine learning classification? If I again ask you, what is the best score, then the answer is here.
If you are working on a classification problem, the best score is 100% accuracy. If you are working on a relation problem, the best score is 0.00.
So can you remember our today's class? We tried to solve two problems. One is the classification problem. Another one is the regression problem, right? So in the classification problem, how we evaluated the classification accuracy, we went, or we tried with the ROC curve and the confusion matrix, and we found our accuracy is close to 90%. I forgot the exact figure, but it was about 90%, like 84 or something. So
85.
okay, 85. And if you are working on a regression, the latter problem was regression, was about regression, and we used to calculate the mean square error, right? And the mean square error was like 2 or 3 maybe. So it's very close to 0. It's very close to 0. It does not like give you like 10, 20, 25, not like that. It was below 5, like 2, 3. So you can also tell that the classification problem was good, like the model was good, decision tree. But who knows, other model could be good fit there. We just used only one model there, only decision tree algorithm. And that is the assignment of you. You can try with another model with the same data set, like decision tree, naive Bayes, support vector machine, neural network, right? You can just apply and you can just select the best model, right? And that is the that should be the objective of a good researcher. So I can recommend you, what is the best prerequisite for a good researcher? Just try to think and try to analyze. And the important word is like, you should have minimum interest. Not minimum, you should have interest. If you have interest in researching, I think research is not a problem. And definitely the teachers are here, will give you some idea the way I'm giving right now, okay? So I'm giving you many idea now. It's your job, whether you want to be a researcher or maybe the any other thing. Anyway,
Evaluation of the performance of a classification model is based on the counts of test records correctly and incorrectly predicted by the model. The confusion matrix provides a more insightful picture, which is not only the performance of a predictive model, but also which classes are being predicted correctly and incorrectly, and what type of error are being made. The confusion matrix is useful for measuring recall, also known as sensitivity, precision, specificity,
while আবার বলো।
specific,
আচ্ছা, next.
accuracy,
Good.
and most importantly, the AUC ROC curve.
Okay, area under curve or rock curve, receiving operating characteristics curve, right? So all the things come from the confusion matrix, right? Recall, also known as sensitivity, precision, specificity, accuracy, and most importantly, area under curve. These all are belongs to one metric. This is called the confusion matrix. Based on the confusion matrix, you can calculate all the other matrices mentioned here. So what is precision?
Precision is the ratio of true positives to all the positives predicted by the model.
Can you explain this one, Koli?
Precision is the ratio of the true positive to all the positive predicted by the model. Sir, একটা মডেলে কত পার্সেন্ট ট্রু হবে? অল পজিটিভস এর মধ্যে সবগুলো পজিটিভ থাকবে, কিন্তু তার মধ্যে কোনটা সত্য হবে, এটার যে রেশিওটা।
একটা এক্সাম্পল দিতে পারবে? এনিওয়ান?
পজিটিভ স্যার হচ্ছে একটু আগে আপনি স্যার ফারহানের একটা উদাহরণ টেনেছিলেন
Oh
যে
my God. Exactly. I understood your query. Next.
Low precision. The more false positives the model predicts, the lower the precision.
এটা বুঝতে পেরেছেন না বুঝতে পারেন?
Low precision. The more false positive the model prediction, the lower the precision. Sorry, একটু more false positives, the more the lower precision, low precision, more false more
টাইপ 1 এরর, টাইপ 2 এরর নাম শুনেছো?
হ্যাঁ স্যার।
কোনটা সিরিয়াস এরর?
স্যার টাইপ।
তারপর কি? কোনটা সিরিয়াস এরর?
টাইপ 2।
তাহলে সিরিয়াস এররটাকে যদি আমরা ফিক্স করতে পারি সেটা ভালো, নাকি যেটা বেশি সিরিয়াস না সেটা নিয়ে তুমি পড়ে থাকলে কোনটা ভালো?
অবশ্যই যেটা সিরিয়াস সেটা নিয়ে সেটাটা প্রেডিক্ট করতে হবে।
ওকে, তাহলে প্রিসিশন তো একটা ভালো জিনিস নাকি?
হ্যাঁ স্যার।
প্রিসিশন মানে হচ্ছে ভালো জিনিস, যার যত প্রিসিশন ভালো সে তত বেশি পাওয়ারফুল, সেটাই তো? ঠিক না? তাহলে একটা ফলস আর একটা হচ্ছে কারেক্ট, ঠিক না? একটা হচ্ছে ফলস পজিটিভ আর একটা হচ্ছে ট্রু পজিটিভ। সত্যিকার অর্থে যেটা পজিটিভ সেটা তুমি যদি বেশি প্রেডিক্ট করতে পারো, সেটা তখন প্রিসিশন কি হবে, বেশি না কম?
স্যার প্রিসিশন বেশি হবে।
অবশ্যই বেশি হবে, কিন্তু যদি মিথ্যা তাকে বেশি গুরুত্ব দাও তখন কি হবে, প্রিসিশন
কমে
কম
যাবে।
হবে। সেই কথাটা এখানে বলেছে। নেক্সট।
Recall sensitivity is the ratio of true positives to all the positives in your data set.
তাহলে দুইটার ভিতরে পার্থক্য কি হলো?
Recall is the ratio of true positives to all the positives in your data set.
আচ্ছা,
অল পজিটিভের মধ্যে থেকে ডেটা সেট থেকে অল পজিটিভের মধ্যে থেকে ট্রু পজিটিভের যে রেশিওটাই দুইটার, এটা হচ্ছে
আচ্ছা নেক্সট।
low recall. The more false negatives the model predicts, the lower the recall.
Right? Okay.
The idea of recall and precision seems to be abstract. Let me illustrate the difference in three real cases.
So you are
First
telling, no, this is the real case number one, whole slide. Okay.
Case number one, the
Mhm.
idea of recall and precision seems to be abstract. Let me illustrate the difference in three real cases. First one is the result of TP will be
TP
that
means true positive.
true positive. True positive will be that the COVID-19 residents diagnosed with COVID-19.
Tell me again. Repeat.
The result of true positive will be that the COVID-19 residents diagnosed with COVID-19.
Okay, next.
Then second one, the result of true negative will be that healthy residents are with good health.
Good.
Third, the result of false positive will be that those actually healthy residents are predicted as COVID-19 residents. Fourth, the result of false negative will be that those actual COVID-19 residents are predicted as the healthy residents.
There is a question.
There's one.
Tell
Which
me.
senior do you think will have the highest cost?
Read.
In case one, which scenario do you think will have the highest cost?
Okay. In case means this is the one case. So there are four scenario. Call it scenario. So how many scenarios? Number one, number two, number three, number four. So if I ask you, which scenario do you think will have the highest cost? And this is the answer. Tell me the answer.
Okay, sir. Imagine that if we predict COVID-19 residents as healthy patients and they do not need to quarantine, there would be a massive number of COVID-19 infections. The cost of false negatives is much higher than the cost of false positives.
Exactly. So which scenario do you think will have the highest cost? The answer is the cost of false negative is much higher than the cost of false positive. This is the case number two.
Case number two, first one, the result of true positive will be that spam emails are placed in the spam folder. Second, the result of true negative will be that important emails are received. Third one, the result of false positive will be that important emails are placed in the spam folder. Fourth, the result of false negative will be that spam emails are received. In case two, which scenario do you think will have the highest cost?
In case two, which scenario do you think will have the highest cost? And the answer is
Well, since missing important emails will clearly be more of a problem than receiving spam, we can say that in this case, false positive will have a higher cost than false negative.
case number three.
Therefore, on the other hand, banks won't be able to make more revenue if the actual good loans are predicted as bad loans. Therefore, the cost of false negatives is much higher than the cost of false positive. Imagine that.
Where are you now? Tell me the case number three. Case number three.
Case number three.
Yes.
The result of true positive will be that bad loans are correctly predicted as bad loans. The result of true negative will be that good loans are correctly predicted as good loans. The result of false positive will be that actual good loans are incorrectly predicted as bad loans. The result of false negative will be that actual bad loans are incorrectly predicted as good loans. In case three, which scenario do you think will have the highest cost? The banks would lose a bump amount of money if the actual bad loans are predicted as good loans due to loans not being repaid. On the other hand, banks won't be able to make more revenue if the actual good loans are predicted as bad loans. Therefore, the cost of false negatives is much higher than the cost of false positives. Imagine that.
So everywhere, the cost of false negative is much higher than the cost of false positive.
Yes, sir. Summary. Confusion matrix summary. In practice, the cost of false negatives is not the same as the cost of false positives, depending on the different specific cases. It is evident that not only should we calculate accuracy, but we should also evaluate our model using other metrics, for example, recall and precision.
So this is the news from the center of Kohli, Center of Excellence Kohli. So Kohli tried to summarize is that the all slides put in one conclusion, and the conclusion is that accuracy alone cannot predict your model. Rather, you should look for other matrices, right? And those matrices like maybe recall, precisions, and all the other metrics that I asked you earlier, or I told you earlier. Okay, so this is the end of Kohli's session. So give a big hands to Kohli. She did a tremendous job, and her pronunciation was good. Okay,
Thank you, sir.
and try to practice more. And I think you are gonna be a good speaker in one day. Who knows, right? Kohli is gonna be the Miss Universe 2020. I'm not sure. It's like the India, right? India won many times. I'm not sure about the Bangladesh. So no need to go for that competition. Even you can go for that competition, no problem. But I would really recommend, or I would really appreciate you try to be a good speaker as far as like the statistician or like the academician is concerned. Okay, and try to speak as an academician, and you will feel good when you will sleep. Okay, when you will sleep, you will feel good. Like the whole day I did something for my listener, for my students, right? I used to talk a lot, and my students were very like angry. Oh my god, what we learned, those was very like noisy, nasty, or not understandable anyway. But at the end, from the true academician, so there are many true and false positive in the academic arena as well. Some teachers, they are the true false positive, true positive, right? So I'm talking about the true positive rate of the academicians all over the world. The true academicians really feel proud and feel honored, right? When they take a class, when they used to talk in front of the audience or the students, right? So this is the one profession like people can enjoy a lot rather than doing other works in other profession. This is my personal belief, and the belief could vary from teacher to teacher, person to person, Miss Universe to Miss Universe, right? So anyway, I'd like to thank you, Kohli, for your good speaking, right? For a
Thank you,
couple
sir.
of minutes, and I really understood and I really enjoyed. Okay, I don't know about your other listener, I'm not sure, but they should understand. If they don't understand, they can revisit the videos. Okay, after the class, definitely the video will is gonna be uploaded by Waresol or someone else, so you can hear again and again, right? So I think you will understand. These are some of the logical things. These are some of the fundamentals or literature based study, but in R programming, everything you're gonna calculate directly. But for the calculation, you need to have some better understanding as far as the literature point is concerned. So I did the job for you. Now it's your turn whether you really want to understand this lecture or not. Okay, thank you, colleague.
Thank you, sir.
Next,
Thank you.
Paran.
Thank you, sir, for giving me the floor.
Great.
Yes. F1 combination, precision, and recall. F1 score. In
Okay.
the above three
So
cases,
what is F1 score? F1 score is nothing but the combination of precision and recall. Once you calculate precision and recall, then if you just combine these two topics in a row, then you can also calculate the F1 score. So the conclusion is F1 score is nothing but the combination of precision and recall.
in the above three cases, we want to maximize either recall or precision at the expense of the other metric.
Hmm.
For example, in the case of a good or bad loan classification, we would like to decrease false negative to increase recall. However, in cases where we want to find an optimum blend of precision and recall, we can combine the two metric using the F1 score. F measure provides a single score that balances both the concerns of precision and the recall in one number. A good F1 score means that you have low false positives and low false negatives, so you are correctly identifying real threats and you are not disturbed by false alarm. An F1 score is considered perfect when it is 1, while the model is a total failure when it is 0.
Exactly. So the news from the center is the score, F1 score, the range is 0 to 1. Suppose you calculate the F1 score for your machine learning model, right? So what you can conclude, suppose you got 1 as the F1 score of your model, then you can conclude that your model is perfect enough because it reaches the maximum point, right? Maximum range. While the model is a total failure, that means it's 0 value. So F1 score 0 means the model is total failure, and this is 100% inaccurate to predict your particular problem. And a good F1 score means that you have low false positive and low false negative. This is the mechanism, or this is the like mechanism of F1 score calculation. So you are correctly identifying the real threats and you are not disturbed by the false alarm, right? But in the real world, you are not doing this one. You are getting the real threats and you are, what should I say, like you are surviving with the real threats, right? In terms of many things, in terms of like many things. Anyway, as far as I'm indicating your department is concerned.
Decision thresholds and receiver operating characteristic ROC curve. ROC is a major visualization technique for presenting the performance of a classification model. It summarizes the trade-off between the true positive rates TRP and the false positive rates FPR for a predictive model using different probability thresholds.
Okay. So what is rock curve? Rock curves definitely a who's calling me? So rock curve is definitely a measure visualization technique, right? So which can be used to present the performance of a classification model. Can you hear me?
Yes, sir.
Okay, so if you want to see the performance of a classification model, you can also use a rock curve. And it summarizes the trade-off between the true positive rate, TPR, and false positive rate, FPR, right? So this is nothing but a graph that will portray or that will display the true positive rate and false positive rate for a predictive model using different probability thresholds. So you have to calculate the true positivity rate. You can also calculate the false positivity rate. Then based on these two measures, you can construct a plot, and the plot is nothing but the rock plot.
The true confusion matrix. The true positive rate TPR is the recall and the false positive rate FPR is the probability of a false alarm. A rock curve plots the true positive rate TPR versus the false positive rate FPR as a function of the model's thresholds for classifying a positive. Given that C is a constant known as a decision threshold, the below rock curve suggests that by default C is equals to 0.5 when C is equals to 0.2, both TPR and FPR increase. When C is equals to 0.8, both TPR and FPR decrease. In general, TPR and FPR increase as C decrease. In extreme case, when C equals to 1, all cases are predicted as negative. TPR equals to FPR equals to 0. On the other hand,
Yes.
when
Okay.
C equals to 0, all cases are predicted as positives. That is, TPR equals to FPR equals to 1.
Let's skip this slide.
Okay, sir. Finally, we can confusion matrix. Finally, we can assess the performance of the model by the area under the rock curve AUC. As a rule of thumb, 0.9 to 1 is equals to excellent, 0.8 to 0.9 is equals to good, 0.7 to 0.8 is equals to fair, 0.6 to 0.7 is equals to poor, 0.50 to 0.6 is equals to fail.
So this is the like rule of thumb of AUC. Once you calculate the AUC from the rock curve also display the AUC. So if the value is like 0.9 to 1, you can conclude your model is excellent. And the classification is accuracy is also excellent, and 0.8 to 0.9 is good, and for other respectively fair, poor, and fail.
Okay, the confusion matrix for a summary you should know. Number one, the confusion matrix for a two-class classification problem. Number two, the key classification matrix accuracy, recall, precision, and F1 score. Number three, the difference between recall and precision in specific cases. Number four, decision thresholds and receiver operating characteristic rock curve.
Exactly. So you should know actually these things, and we already discussed throughout the lecture of Miss Universe Koli and Miss Universe Farhan, right? So I think you
Mr.
already have a
Universe.
Mr. Universe. Okay. So I think you already have a good understanding about these topics. Okay. Thank you, Farhan, for your outstanding pronunciation and no fault when you were talking with us. Okay. Your pronunciation was perfect, and you are very slow. And I think the students should understand very clearly what you tried to tell them. Okay. So keep the good things with you, right? Try to learn more and more. I'm not sure about your current status, but you should practice more, okay? And show the society you are capable enough to do some better thing, okay? So thank you, Farhan. Next, another miss is coming. Oh,
Amrin, sir.
yes, Amrin. Miss
Oh,
Amrin.
thank you, sir.
The floor is yours.
Thank you, sir. How do you measure the accuracy of a machine learning model? It also about confusion matrix. Confusion matrix bases on TP by TP plus FP.
You
that
have to
means,
pronounce what is TP.
True positive divided the summary of the summation of true positive and false positive, and then sensitivity, true positive divided by true positive plus false negative. Specificity, true negative divided by true negative, and addition of false positive. Accuracy means the summation of true positive and true negative divided by the summation of true positive, true negative, false positive, and false negative.
Can you summarize this table?
Prediction classes and actual classes,
Mhm.
and then positive, negative, sensitivity. Oh, yes. False negative type 1 error, false positive type 1 error.
Okay, you can maybe understand later when you will go back your home.
Here, recall and precision. Recall is the percentage of the total relevant documents in a database retrieved by your search. If you knew that there are 1000 relevant documents in a database and your search retrieved 100 of these relevant documents, your recall would be 10%. And then precision, the percentage of relevant documents in relation to the number of documents retrieved. For example, if your search retrieves 100 documents and 20 of these are relevant, your precision is 20%. The set of items
Okay,
I
no need.
can see there
Mhm.
later. And
So in this picture, you will have understanding what is true positive, false positive,
false
false
positive.
negative, true negative. Just try to explain. Healthy people like this, you can just tell, and this is this, this is this, this is just tell like this. What?
So here actual values and predictive
You can
values.
follow my.
Sick people correctly predicted as sick by the model if true positive is 30, and healthy people incorrectly predicted as sick by the model if false positive is 30. And then sick people incorrectly predicted as not sick by the model if false negative is 10. Healthy people correctly predicted as not sick by the model if true negative value is 9, 30.
These are the actual values.
Actual values,
Actual.
the predicted values. And then ROC curve. And ROC curve, receiver operating characteristics curve, is a graph showing the performance of a classification model at all classification thresholds. This curve plots two parameters, true positive rate and false positive rate. And the meaning of true positive rate is a synonym for recall and is therefore defined as follows. TPR is equal to R divided the summation of TP and in addition of FN. False positive rate is defined as follows. FPR, false positive rate, is equal false positive divided by the summation of false positive and true negative. And then ROC curve plots TPR versus FPR at different classification thresholds. Lowering the classification thresholds classifies more items as positive, thus increasing both false positive and true positives. And here we can see the graphs. The following figure shows a typical ROC curve. True positive versus false positive rate of different classification thresholds.
Exactly.
And then we can see the ROC curve also, true positive rate and false positive rate, and random classifier, better, and worse.
There are three classifiers here,
Yes.
right?
Yes.
So which one is the perfect one? This is the perfect. Why this is the
Perfect.
perfect?
Better.
Because the true positive
Yeah.
rate is like 1, right?
Yes, sir.
And this one is better. Why? Because the positivity rate is lower than the perfect. And this is the worse. This is the worse because
Lower than
the
0.5 or 0.6.
exactly less than, right?
Less than.
Exactly.
Yes.
So this is the ROC curve classification.
And then to compute the points in a ROC curves, we could evaluate a logistic regression model many times with different classification thresholds, but this would be inefficient. Fortunately, there's an efficient sorting based algorithm that can provide this information for us called AUC. AUC stands for area under the ROC curve. Area is AUC measures the entire two-dimensional area underneath and the entire ROC curve. Think integral calculus from 0, 0 to 1, 1. And here figure 5, we can see the area under ROC curve and true positive rate and false positive rate. So, and area under curve provides an aggregate measure of performance across all possible classification thresholds. One way of interpreting AUC is as the probability that the model ranks a random positive example more than highly than a random negative example. For example, given the following examples, which are arranged from left to right is ascending order of logistic regression predictions. Actual negative is assigned as red color and actual positive is assigned as green color. And the figure is about predictions ranked in ascending order of logistic regression score. AUC represents area under ROC curve represents the probability that a random positive green example is positioned to the right of a random negative example. AUC ranges in value from 0 to 1. A model whose predictions are 100% wrong has an AUC of 0.0. One whose predictions are 100% correct has an AUC of 1.0.
No need. Anyway, so there is nothing left behind for the remaining presenter, Mr. Murshid Alam. I'm really sorry, maybe in the next class, or maybe you can have the opportunity to present something. Okay, I really forgot the volume of today's lecture.